Welcome back to the shrine. Today we are going to explore the super exciting topic of hand mixers. And these are kitchen hand mixers, and I'm talking plural because I got the new one here and then the old one is properly put in a box. We never throw anything away. We just live in a big house, and then someone one day is gonna clean it up. So this is the old one. You can see the patina, the age on it. There's nothing wrong with this guy other than, and you can see I turn it on and it works. Both of the shafts are spinning. The problem is with these beaters. So these are the dough beaters that it came with. You know, you can use these for dough, you can use these for batters, and well, that's the typical failure mode. So this prong here came loose from the shaft, and at that point this is pretty much a throwaway part. What they did here is they got this shaft and they made a groove, and into the groove this part is either brazed or welded, some kind of method or technology. I think all 4Ds are the same shape. It has this crescent shape indentation, and you can see it should just go in, but it kind of pops out. So both of them failed the same way. Obviously, you know, one fails and then wife still keeps using it, and then the other one fails shortly after. When we got married, the big question was, should we buy the big and expensive KitchenAid mixer for 250 bucks that takes up basically this much space, you know, as this cutting board, and every time, you know, you need to store it somewhere, so it either needs counter space or need storage space somewhere, and then it's heavy to move. So anyways, we settled on these, and over the years we probably had 5, 6, 7 different ones. They last typically 2 or 3 years, and then something inside fails and we just get a new one. So they typically cost about 20, 25 bucks. And I'm big at repurposing. This is my throwing stand in her entire beauty. You can see these are the calipers that are touching to the wheel, and then I repurposed one of the mixers. So this would be the shaft. So this is the shaft, and then you can see it's engaging the gears and so it's opening and closing this caliper. So that's one of the ways to use an old kitchen mixer. So my wife went ahead and bought a new one. This is also Hamilton Beach. It says professional. Hamilton Beach professional. I'm not sure what professional about this is, because I used it 2 or 3 times, and I gotta tell you, this is the most anemic mixer I ever had. I didn't look into the performance rating on mixers, but this is by far the weakest one we ever possessed. So it says 120 volts, 60 hertz, 1.3 amps, 120 watts. And then the old one, 120 volts, 60 hertz, 1.8 amps. So if this is 120 watts, I would say this is around 200 watts, because it's drawing a higher amperage. This is 1.8, that's 1.3. So we're gonna go take it apart, have a look-see inside, see how they are built, what the differences are. Better to unplug it before I pop the cover off. Huh. Well, as I said, it shows the age. You can see there's some patina on it. All the batter and dough we ever mixed with it, probably a lot of it, was circulated through the motor. So what do we have here? Again, this is the old one. Looks like we have a wound field motor. And and it's got multiple field coils here. You can see multiple terminations on the field coils. Looks to be connected in series with the brush holder. So this is the field coil, and from the field coil there's a lead that's coming out here, and it's connecting to the brushes. So here's one of the brushes, here's the other brush. You can see the same thing on both sides. This termination of the field coil just directly attached to the spring, and then the spring is pushing on the brush, and then the brush is touching the commutator inside the motor. So this is a wound field motor with a series armature. And so we got AC coming in here, and that AC runs to some kind of selector switch down there, and then from the selector switch these wires come back on and then feed this AC coil here. There's a label on it. It says 120 volts, 60 hertz, 200 watts. So here's the new one, and it's a different construction. Size wise it's about the same. You can see the new motor is shorter. So what we got here is we don't have field coil, we have permanent magnets. So this is a permanent magnet. Looks to be this is a DC motor. So there must be some kind of electronics down there that's rectifying the voltage, because we got AC in the outlet. Same kind of layout on this motor. You can see we have one central shaft. It has a high pitch screw thread here rolled on it, and that is engaging these two plastic wheels, and then the plastic wheels have these holes where you can put the beaters. So you can put these beaters in these holes. Other than that, it's all aluminum. The front housing, the rear housing is aluminum. These are plastic insulators that hold the brushes. So the wires that feed the motor directly connected to the brushes, obviously you don't have to power the field coil because there's no field coil here. There's two arcuate magnets. These are the cheapest ferrite magnets that are out there, probably bronze bushing in the front and the back. You know, this is built to cost, so the manufacturer is trying to save every penny on these. If we buy these for 25 bucks, they gotta make them for, you know, half of that, because Walmart also want to make money on this. So let's pop the motor out. You can see the motor is on these dampers. So there's a damper on this side, there's one here, and then it's bolted on the front. And then this one has 4 bolts, so all the corners are bolted on this one. Here's the motor. It's got some writing on it. 120 volts, 60 hertz, 1.3 amp, 120 watts. So this motor is 200 watts, this motor is 120 watts. So obviously this motor is not producing the same amount of torque, and that's why it seems to be really weak. Makes me wonder how they rectify the current and how they provide the various speed to the motor, because this is the speed selector here. So there's 5 levels, and then there's a burst mode. So I just want to go there and see how it's put together. She's gonna be stoked if she figures out I took this apart. I counted 8 or 10 different bolts so far. And what I typically do is I put the bolts back into the components where they belong if I'm repairing something. This is not a repair, this is clearly just a tear down video. You can see they had these bolts. This is a different one. There's a different set here. So there's 5, 6, 7 different styles and shapes and length bolts. Okay, looks like everything came out in good shape. So this is the control electronics. Let's see what we got here. So this is the switch that is gonna turn it on and off, and also it is switching all the different modes, so the different speeds. And then we have a micro switch here. This is what actuates the burst mode. Other than that, we got a couple surface mounted resistors, capacitors. Here's a switch. Yeah, so this guy is an RS608C. That's a bridge rectifier. So when AC comes in, AC comes through these two black and white lines, goes right there, and then this rectifier is going to rectify that. And then other than that, it doesn't have anything else. There's no micro on it. As you can see, there's no micro. The micro would be expensive. So this is all basically analog circuitry to control the voltage that goes to the motor. Again, this guy, you can just put the AC voltage on the motor, and this motor is going to turn from the AC voltage that is coming from the outlet. But for this motor, you first need to rectify it. So there's a capacitor here. This is probably smoothing out a little bit of that, you know, dirty low voltage that's coming from the outlet. So why don't we turn this on and then do some measurements on it, maybe see what voltages it produces. Plug this thing in, turn on my voltage, make sure I don't electrocute myself. Okay, so first one is 32 volts, second one is 51, third is 74, fourth is 95, the fifth is 121, and then let's see what the boost does. So the boost goes up to 128 volts. So as you can see, it's not much, and I got the meter on DC voltage, so really this electronics is feeding DC voltage to the motor. I don't see much arcing and sparking at the motor. It's nice and quiet. It doesn't vibrate much. And it's all analog circuitry. Probably that's how they're keeping the cost down. It doesn't change the fact that this is a really weak mixer. I do not recommend buying this mixer. This is only 120 watts and it's faltering when mixing some thicker dough with it. And just like that, it's back in one piece. And then this cable management system, you can see that from the inside. I really have no idea what it's doing. So you can see it, you can lock it to the left and you can lock it to the right, but all it's doing, it's hinging. And then look at this, they have a zip tie here, and then they have two bolts and a clamp clamping the wire down, so they wanted to make sure that wire doesn't go anywhere. I think this might be one of the failure modes when that cable pulls out. I think that's what they tried to remedy with it. And then I was also looking at this shiny piece here. So you can see it's got a shiny piece. So that's a separate part, and it just snaps in. You know, everything here is about cost, but you also have to make a product that people will buy. So it has to have some shiny parts. You can't just sell something black. You can see there's a design here going on. So this is black, you know, this is silver. There are some lines, there are some terminations. So the design team put a heck of a lot of work in it. I did not try if this eject work. Oh, look at that, it works. It does work. So there's a cam and lever mechanism under the motor inside. When you pull this trigger, that pushes that out. Which I used this like 5 times. This was the first time I saw the lever. 2 mixers, Hamilton Beach, both of them. Should we do a torque test on these? Just connect them together and then see which one strips the gears first. Put it in the comments below. As far as analysis, I think this is a lot better one. It's 200 watts. It's built better. This is Anemic. Don't buy this. Thanks again for stopping by. Hope you enjoyed the video. See you on the next video. Bye.